Okay, this is another calorimetry problem. So I've got a block of ice cooled to negative 78 Celsius, and then I put it in some water that's in a copper calorimeter that has some temperature, and it's all going to come to equilibrium. Okay, so first, like all the other things, right? First, let's write out the stuff we know. So I know my mass of the ice. I know the mass of the water. I know the mass of the copper, right? I know the specific heat of ice. I know the specific heat of water. I know the specific heat of copper, right? And I know the latent heat of fusion of ice. So my latent heat of fusion is 3.33 times 10 to the fifth. My specific heat of copper is 387. Water is 4,186. Ice is, 2,090. My copper mass is 80 grams of copper, so 0.08 be in kilograms, right? Base units. My mass of the water is 0.560, right? I'm converting, grams needs to be kilograms. 40 gram block of ice, so 0.04. And now I have all this. So now I can go start solving stuff. Okay, so how are we going to do this? So let's do this piece by piece. So let's do the heat gained by the ice. Great. So the heat is going to have to gain some ice. The ice is going to have to gain some heat in order to change temperature, right? So the ice is at negative 78. So what's the heat gained by the ice? So I'll call this H1. So the heat gained by the ice is going to be the mass of the ice times the specific heat of the ice times the change in temperature of the ice. It went from negative 78 to 0. So that's going to be 78. That's my change in temperature. All right? Okay. So MC delta T plus the mass of the ice times the latent heat of fusion plus the mass of the ice that got melted into water, right? So the ice had to change temperature from negative 78 to 0, and then you had to melt it, and then you had to heat it up, right? So that times specific heat of water times TF, which is what I'm trying to solve. Okay, so I can plug all of this in, and I can get some number, right? So if I plug in mass of the ice, specific heat of the ice, all of this stuff, right? I can get some number, right? I'll just call it this, underline, right? Plus mass of the ice, specific heat of water times T final. I don't know T final, so I'm just going to leave this part alone. I'm just going to call it MCTF, right? But I have a number here. Okay, now let's do heat lost by water. Heat lost by water, I'll call that H2. Okay, so the water is just mass of the water times specific heat of the water times the change in temperature of the water. So the water went from 80 grams, temperature 25. So it went from 25 to something. So 25 minus TF. Right? So that's equal to mass of the water, seawater, times 25 minus mass water, seawater, TF. Okay, so when I do this one, again, this is going to be a number, and I'm going to leave this one as a variable because I don't know TF. But I can multiply mass of water times specific heat of water times 25 and get another number. And so for H2, I'm going to get something minus mass water, seawater, TF. Okay, now I got H2. So 3. Now let's figure out heat lost by copper. So the heat lost by the copper is H3, and that's going to be MC delta T. So that's copper, C, copper, times, same thing, it's at the same temperature, so it's going to be 25 minus TF. And then, so that's going to look exactly the same as this one, right? So it's going to be M copper. C copper times 25 minus. Okay, so now I have H1, H2, and H3, and these are some number, right? So let's go figure out what this is going to be. So if I combine all three of these equations, H1 is equal to H2 plus H3, right? The heat gained by the ice is equal to the heat that the water lost plus the copper lost. So if I combine this equals this plus this, what it ends up looking like solved, right? I'm just going to skip the algebra doing that. The solved equation looks like this. It looks like this. Final temperature is the number here, H2, plus the number here, just the number, right? H2 plus H3 minus the number I got for H1. Divide that by mass. This is basically the sum of all the mass times the specific heats. If you do that, it'll give you your final temperature. So it's just a lot of work. So what you have to do first, put all your variables down, right? And then do each one of these. Do the heat gained by the ice, do the heat lost by the water, heat lost by the copper. Combine all three using this, right, where this is just the numbers and you leave the other parts as variables. And then that'll give you the final temperature.